Do subscribe to IIT channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Hello students, let's solve question number 16 of JEE Mains 2017 physics paper. So let us solve question number 16. Hello students, let's start with question number 16. So far we have discussed about the last 15 questions. This question is about the capacitor and resistor circuit, CR circuit, and in the given question, the circuit diagram, we have seen that the question is when the current reaches steady state in the circuit, the charge on the capacitor of capacitance C will be. So this is a question after steady state. We know that when there is a capacitor connected to with resistance with the battery at steady state, obviously steady state is attained after infinite time, but after steady state, where that means the capacitor is fully charged, that branch of the electrical network is disconnected from the total circuit. That means at steady state the capacitor behaves like open circuit, so there is no current flowing through that branch of the capacitor which contains a capacitor. So that means at steady state current will not flow through this. Then what is the charge on this capacitor at that time? So at that time, whatever is the potential difference between those 2 points, that will be the potential difference across this and across this, because all these three are in parallel. So whatever is the potential difference across this, that will be the potential difference across this, and that multiplied by C is the charge on the capacitor at time infinity. So initially, during that time I will draw a diagram for steady state. For steady state, the diagram will be like this. The battery resistance internal R, or may not be internal, we don't know any resistance. Suppose this is internal resistance, obviously, because this is RE. Even if not internal, doesn't matter. The capacitor is here, and there is a resistance R1 over here and a resistance R2 over here. Now at steady state time infinity, this capacitor will behave like an open circuit, so this is disconnected. So this is disconnected. What is the potential difference across the capacitor? Suppose the capacitor potential difference across is V, the capacitance is C, the charge C into V. So this is the V at time infinity. So at that time infinity, what is the potential difference across the capacitor? Because the current through this at that time is 0. So whatever is the potential difference here, the same potential difference will be here. So if this point is suppose A, this point is B, this point is C, this point is D, and this point is E, this point is F, then the potential difference between E and F will be potential difference across C and D, because they are parallel, and whatever is the potential difference across this is the same potential difference across A and B, and because there is no current flowing through the capacitor at time infinity. Therefore, I can say that this potential difference is actually VAB, potential difference across these two capacitor plates, and that is same as BDC, that is same as BEF. So I have to find the potential difference across these two. How to find the potential difference? Because when this is disconnected, I have to find the current that is flowing through the circuit. Because this positive is here, so suppose current is flowing like that, that current I is not flowing through this, is only flowing through this branch, this circuit, and here and here. This is how current is flowing clockwise sense. Now what is that current? Now the basic question is to find the potential difference between these 2 points E and F. To do that, I will use the general process, or I can use the Kirchhoff's voltage one, or in any way I can get the value. We know that in case of a battery, here I can suppose that this potential is 0 here. I can consider this potential 0 here. So potential of F is, I can consider, is 0. You can take 0 potential at any point. I can consider potential 0 here. Then this, when I come to this, the potential here will be E, because this is plus, increases by E, and the current is flowing like that. If I move with the current, the potential will drop. So when I reach here, the potential will drop by E minus, because this is E here, so it will be minus, because there will drop of potential is current into this resistance. So if I see here the potential difference between these 2 points B here, so this is the potential at E, so V minus VF is the potential EF. This is what is the value here. So this is what is the potential difference. Then I have to write the answer in terms of not I have to replace I. E is okay, small r is okay, but this I is not okay, because the options are not in the form of I. No I is there. So if I put this value here, the charge on the capacitor will be C times this potential difference, which is coming out to be VE value is E minus IR minus 0. This is E minus IR. So putting that, I'll get the charge on capacitor at time infinity equals to C into V of EF, that is C into, now we got E minus IR. This is the chart, but then I have to reduce or simplify this I don't want this I. Then at time infinity, if I go for the calculation of the current that is flowing, the current is flowing in this branch, because this is like open circuit. So net resistance is R plus R2. This is net resistance, this is a EMF E divided by R plus R2. Using Ohm's law, I have I equals to E divided by R plus R2. This value I'll substitute here and solve. This is C E minus E divided by R plus R2 into R. This I will solve. E can be taken out. Now this is 1 minus R divided by R plus R2. If I solve this, this is CE. This goes over there, R plus R2 minus R. I will cancel that R, and this is left with charge on that capacitor at infinity time is CE into R2 divided by R plus R2. So if I see the options, then C R2 divided by R plus R2. So this is the correct answer to this question. Thank you.